Okay, let's get started. Um, welcome back. Um, Today we will make a very brief recap of the verifiable credential and verifiable presentation data format, the triangle of trust, really in few minutes, and then we'll go through the security and privacy consideration that we as adopter or developer of one of the entity of the triangle of trust have to consider to avoid security vulnerabilities or privacy leaks. So, to recap, at the third layer of the SSI framework, we deal with the triangle of trust in which one or more issuer interact with the holder of verifiable credential, and the holder use verifiable credential to interact with verifier. That means they present through the verifiable presentation data model their verifiable credential. At this layer, there is the real interaction between the three entities. I mean, the DID that we covered at layer 2 of the framework are not directly exchanged between the peer, but since the DID is in the credential subject, so the issuer bind a specific verifiable credential with a DID of the subject and holder of the verifiable credential itself, so the exchange happen at this layer. So we really exchange only verifiable credential and verifiable presentation. The issuer issue verifiable credential to holder and sign the verifiable credential. Holder through, for example, a wallet, generate verifiable presentation that, in roughly speaking, is a wrap of a verifiable credential signed by the holder itself. These presentations are presented to verifier for authentication and then authorization to services or resources. So what is a key point in the community of developer is that there are typically three types of communities. The one that are discussing and implementing the issuer side, the other really interested in the older side. So people that are designing and developing several different type of wallets, and the verifier community also. So all that part of the community that is interested in building the business of the verifier side. Of course, these three community need to and are interacting among themselves, and coming to this consideration, it is very important that these three subsets of the community are aware of this consideration when they specify, design, and implement, because ignoring some of the consideration that we can read in the specification can lead to security vulnerabilities. So, starting with security consideration, cryptography suite and libraries. As you know, there are a lot of libraries that provide implementation of this framework or of particular algorithms that are used by this identity, and also different crypto suites. We So some example, if I remember correctly, last lessons. It's very important that developer know very well these crypto suites, the properties of the algorithms behind these crypto suites, also possible cases of vulnerability of this library and crypto suites. And so is also key that when you really want to develop some of these agents, issuer, wallets, or verifier, you also uh, take into account possible updates of the crypto suites or of the library. That's, let's say, super important when in the real world you start doing this kind of development, because it happens very, very frequently that libraries, some vulnerabilities are found in libraries or in the crypto suite. And so you have to constantly be aware and check for possible updates of these building blocks. If your system is already in place, this means that in some cases, you have to reconsider also the validity of the verifiable credential that, for example, an issuer has already issued. Because at that point, that credential can be misused, for example. This is why it's so important, and we also push a lot on this, is the revocation mechanism for any identity system. Because in some cases, you are forced to revoke some credential and of the whole set in very bad cases, and refresh or reissuing the credential. So this is something that go beyond, let's say, the core principles of this framework, but something that we really need to consider when we want to do something in the real world. Then key management. Key management, in particular at the issuer and holder side, is very important for the security of the whole system, because security typically depend on the quality and the protection of the secret keys, private signing keys, secret keys. In the specification, there are numbers of NIST documents, standards that must be considered to implement a proper key management. Few guidelines. It's very important. Key rotations. So implement a solution for rotate the keys after a certain period of time. Solution that really provide secure storage of the private keys in software or in hardware when possible. Overall, key management is something that you have to consider really carefully to avoid possible vulnerabilities. Content integrity protection. We also see these when we talk about the DID documents. It can happen that an issuer decide to link within the credential subjects some external resources. These resources can also change over time sometimes, and so it's very important that we implement a proper solution for checking integrity of the URL that point to the resources and to externally to the integrity of the resource itself. So this means that beside our issuing role, if we decide to link or to bind in the credential subject a credential with some external resources, we also need to consider, or at least being really aware of the integrity protection mechanism that are implemented outside the framework of this identity model to protect the integrity and the validity of the information within the credential subject that the issuer is standing for. Then, unsigned claims. You know that sometimes we can produce self-asserted verifiable credential, or as we will see in few slides, other credentials that are called bearer credential. For Italian people, credenziale al portatore. Something that I really have and can share just to provide some information to a verifier. But this is possible, being at the same time in line with the specification of this verifiable credential. But remember from the name verifiable credential that a credential becomes verifiable when all the credential is protected by the signature of the issuer. So if in your application or system you want to use such a kind of verifiable credential, be aware of the purpose of the credential as an issuer, and also as a verifier, pay attention to the authorization mechanism and the reasoning behind the authorization process that you put in place when consider this kind of credential. I can say that this specification really, thanks to the extensibility purpose, extensibility feature of the data model itself, really provide implementer and developers freedom to create any kind of verifiable credential and assert the claim that you want. But we need really to pay attention to what we are certifying in some sense. Man in the middle, replay, and cloning attack. Well, first point to prevent such a kind of possible attacks is the use of proper TLS protocol. When we consider the self-sovereign identity as an identity model that works at the application layer, is very important that any interaction between the entities in the triangle of trust happen after the creation of a secure channel based on TLS 1.3 and shakes. This provides us a solution to counteract man in the middle, cloning, of course, but pay attention also to replay. So if you remember, one of the properties that you have in the verifiable presentation data model is a challenge. So nonce, a fresh random number provided by the verifier, such that you create a fresh signature that has a validity for a given period of time. So it's not only the challenge, the key point, but also the validity period. So if I receive back a verifiable presentation that has correct signing, but after a given period of time, I can reject it because I'm not fully sure of who is the entity on the other side presenting that credential that has made use of the random numbers, the random challenge that I provided to the holder. Spoofing or cloning means that is super important to store securely the verifiable credential at the holder side in the wallet, because this can happen in transit but also at rest. So we need to consider proper security mechanism to store the verifiable credential. That's why, also because is absolutely not a good idea to store verifiable presentation. So normally the holder generate a verifiable presentation on demand when the wallet, the end user decide to present the credential. Bundling dependent claims. To understand this consideration, let's make an example that you can also find here in the specification. So, for example, consider a university issuing two verifiable credentials to an individual. Each credential contains two properties that combine indicate a person role in a specific department. For example, one credential pair may designate staff member in the Department of Computing, while another could, for example, designate postgraduate student in Department of Economics. You know that you can also combine credential. And so we have to pay attention when we decide to issue, in this example, the credential, because we need to avoid that a malicious holder user, for example, put together staff member in Department of Economics, because you are not a staff member in that department, you are a staff member in Department of Computing. For what regard the Department of Economics, you are just a postgraduate student. So from the authorization point of view, you are allowed to do some activities and other not. So it's very important, since holder can combine the credential, that at issuer side we really consider how to assert those roles in the credential. That means, for example, I provide you a single verifiable credential in which I can state your different roles and departments, such that you cannot recombine as you want the claims, for example. So these are all kind of stuff that let's say that at the beginning we don't consider, because we want to implement the model, but we really need to carefully select the kind of credential that we are really issuing to the holder, to avoid misuse, or to give the holder the possibility to, let's say, present a false claim because they simply combine verifiable credentials. Highly dynamic information. This can happen that we put specific claims in the credential subject representing the role, the identity, or any characteristic of the user, but this can change sometimes very frequently. So it's not a good practice, for example, to provide those kind of verifiable credentials without very well considering the validity period of the credential itself. So why I have to, for example, put validity of 2 years when I know that that characteristic can change really frequently? And so, in that case, consider a proper value for the validity period is important. This is not the case for verifiable credential that state, for example, your degree here at Polytechnic of Torino, because it's lifelong. Once you get it, you have it. No? So it's really important that based on the kind of information that you are putting in the verifiable credential, that you consider the validity period. Otherwise, sometimes malicious user can reuse those credentials presenting valid but false claim, because the verifier in the end can authenticate use, can validate the word credential, but the claims are no more valid. Device theft and impersonation. This is a consideration that target, in particular, the older, so typically the wallets. Wallets must implement security mechanism, strong security mechanism that provide the end user, so the real person, or in some cases the object that use the wallet to authenticate the user itself with the wallet. Otherwise, some malicious user can reuse your credential and get access to services or resources that they are not allowed to use or to access to. Acceptable use. This is also really important because, for example, the property term of use bind the use of a specific credential only with the term that are specified by the issuer. And so for some verifier, it's very important to consider this term of use to understand if a specific verifiable credential has been presented for the right purpose. So taking into consideration not only the claims themselves in the verifiable credential, but the real meaning behind these claims is important. And so we need to take and pay attention to the purpose of the issuer that has provided, has issued this credential to the holder. more or less a lot of these considerations are sort of warning about what we write in the credential subject. So this is, let's say, the other side of the moon of having full freedom to put and describe the identity of people and objects or organization as we want. So when you design your verifiable credential as an issuer, and also you as an implementer of the verifier service need to carefully design the type of claims, the type of information that you put inside, the purpose, the real purpose of the credential, and be aware that beside authentication, you consider carefully the authorization that specific credential give to the holder of the credential itself. Code injection, this is super simple. Avoid putting scripting and code in the credential subject of verifiable credential. Now, privacy consideration. So first of all, let's consider the full spectrum of the privacy topic. For sure, this is completely dependent on the use case. There are, let's say, solution which we use in credential highly correlatable information. These are, for example, any global ID, because we can link the behavior of the holder behind this credential. The global ID in the credential itself are something that we can read and understand to then profile, for example, the user itself. If we move to, and so this kind, if we decide to use such a kind of information, for sure, we are in a, let's say, a use case with less privacy. Moving forward to other solution in the middle, in which we use other information that can be due to colluding verifier or verifier and issuer, can also make possible to link and profile the behavior of an holder of a particular presentation. Of course, when we move to pseudonym, we are for sure in a system where we can have more privacy. The typical example is the age. So above 18 in Italy, for example. Above 18 is a claim that does not provide any further information to the verifier or to entities that use and validate the credential. On the other side, look, for example, at your identity ID, the one that you have in your pockets. I can also understand if you are over 18 or not, but at the same time, I have your birth date and a lot of other information. If I have to accept or not to enter a particular shop, for example, only if or to sell you a particular goods. Only if you are above or below 18, why I have to understand more information about you as a user than the one that is only required. So this means that you are going in the future to deploy a system where this kind of verification is important. Why not to consider a simple issuer that can provide, after proper verification, simply a verifiable credential that state you are over 18. I don't have to put inside name, surname, birth date, or any other information that you, on the contrary, have on your ID, your physical ID. So privacy means I want to provide the minimum set of information to the verifier to let him take the decision to accept me or not, to authenticate me and then authorize me to the service or to the resource. This is the spectrum in which we are moving, and we are discussing privacy consideration. For me, the key point is data minimization. If I'm designing a verifiable credential for one purpose, I have to put inside the minimum set of information that the verifier need to take his decision. Of course, and this is something we will see in next lessons, I can also, for example, decide to put more information within one single verifiable credential. But in that case, I have to provide the holder the capability of what is called selective disclosure. So I have a set of 10 properties, but I want to give the holder the capability to select, based on the verifier is interacting with, which of these 10 properties of my identity share in clear with the verifier and which not to disclose. With this approach, is not only, let's say, the issuer that take the decision on the granularity of the disclosing information, so only the issuer that decide in which of this spectrum, privacy spectrum, the system works, but we also give the user the freedom to take his own decision on his own data. Self-sovereign, if you consider the words of this name, is we as a user want to have full control on the data that we use and share to build our identity and to interact with others. So self-sovereign comes from this concept. Okay, let's go through some of these considerations. The privacy of the user in this framework, as of course in others, really depend on the real implementation of the software entity, software agent that we put in the hands of the entities of this triangle of trust. So an issuer is expected to issue verifiable credential only to individuals that the issuer assert have completed their educational program, for example. So if we need to put trust in the software that we use, and we expect that the issuer really verify what they are putting in the verifiable credential. On the other side, a verifier is expected to only allow access to individual with a valid verification status for verifiable credential and verifiable presentation. So we also need to trust the verifier agent that provide all go through all the step of verification and validation and authorize correctly the properties in the credential subject and behave correctly in this sense. Of course, that's also super important from the privacy point of view. We need to trust the wallets that we decide to use, because we want to be sure and we trust the wallet once we know that this wallet does not provide under the hood more information than the one we as a user select to disclose to the verifier. The idea is that in this framework, essentially the user expect the software they are using to operate in the user best interest. So we, as a developer of any implementation of this framework, must consider this aspect. So we need to implement the agent considering the best interest of the user. That means issuer must implement proper process to verify. And typically in the real world, the identity of the end user and don't store, for example, key privacy related information in their own database. So once me as an issuer has verified and I'm ready to stand for a claim in your verifiable credential, if there is no reason to store this information, don't do that. The same at the verifier side. Once I have authenticated you and use the properties in the credential subject to authorize, I don't have to, there is no reason to store this information. Of course, when we move from being a developer to user, is our it's our duty to control the behavior of the software and change from one implementation to another to be sure to trust really to trust the software that we are selected for interacting in this ecosystem. So the point is that from the privacy point of view, data minimization, implement the software such that this software is trusted from the behavior point of view, so behave correctly as an issuer, correctly as a verifier, does not provide further information than the one selected from the end user when you interact with your wallet. So this is something that we need to consider when building our solution. Personally identifiable information. Everywhere possible, avoid the use of personally identifiable information in the credential subject. So what the specification is essentially telling us is again data minimization. So the classical example, if the don't use date of birth, but where the purpose of the credential is understand you are above a certain age, use the properties, for example, age over. Personal information where must be used for some particular reason in verifiable credential, again, tell us immediately, for sure I have to protect this information in transit. So the use of a right TLS implementation, but also at rest. So we come back to the previous point. Also, storing correctly verifiable credential in the wallets is a must. Now, three possible surface for correlation. What does it mean? Essentially, correlation means me as a single verifier that I start tracking the behavior of a particular user, considering the verifiable credential that is presenting, but also in case of colluding entities that put together the information to further profile. All the information that can be used for correlation and for linking are all the identifier. The identifier and verifiable credential means the ID. That's why, if you remember, we also consider the possibility of using pairwise DID, at least between different verifiers. The unique ID of the credential itself is also something that we can use for identify a particular credential and user, and then start profiling it. The metadata are a particular case or particular information, and in this we have to consider, for example, the number of users in our ecosystem, because, for example, let's make the example of the properties valid from or created, and in particular the time at which a particular verifiable credential has been issued, or the signature made on the credential itself by the issuer. How many depend on the granularity, essentially, of this time information. How many credential an issuer can have issued in that particular time span is unique. So we can use it to really understand that you are constantly accessing a service, or if in the time span that depend on the granularity of this information, an issuer can also issue a high number of credentials, identifying is more difficult because there can be different users that present the same credential with the same value in this metadata. So also the number of user in the ecosystem itself. If there are few users, it is easier than the case of scenarios in which we have millions of users that have, for example, that are holding we can use, for example, in this case, the issuer property. So if there are several millions of people, of users that have a credential from a particular issuer, it's difficult to use this information to identify a particular user and then start correlation. Another possible information for correlation is the signature. Because the signature, when the signature is always the same value, I can use it to identify and start linking the particular user. This is why challenge or nonce can be used by the holder itself or by the verifier to, let's say, force the generation of a fresh signature every time an holder decide to provide, to generate the signature. Now, device tracking and fingerprinting. This is something I thought a lot on. And let's say this mistake typically happens when we focus a lot on a particular layer of the overall system solution that we are developing, and we don't consider what happened around. We can have the most privacy preserving solution, for example, for identity, but remember that we can use TLS to protect also in transit or any other solution to protect at rest those information, but we are exchanging information through IP networks. So at IP networks, I can track you because you have always the same source address. So at any layer of the TCP IP stack, I have information that I can use to track and profile you as a user. So please consider this. Or when you decide to use information from Galileo or GPS navigation system or time information from these systems, no? So you are putting information from different systems. Sometimes the sum of and the use of two information give someone else more information than the information that you can gather from the single two information. So you have to consider also the what is around the simple identity framework, because sometimes privacy or capability of tracking and correlate end user are depend on the whole technology that you are using. Again, on this point, the specification stress a lot. Favor abstract claim. This is something for the issuer. So data minimization, again, is very important. The use of pseudonym, avoid as much as possible the use of personally identifiable information. So this is something important from the issuer point of view. But at the same time, the principle of data minimization is something important also at the verifier side. If you decide to use plain text verifiable credential with a lot of information inside, or selective disclosure credential in which you can select which one to uh, to present, to disclose, and which not to disclose, the verifier also need to implement an authentication, authorization process using the minimum set of information. So the verifier is super important in terms of privacy because they decide the information that they want to give you access or not. So implementing the verifier taking into consideration data minimization is important. In fact, the specification tell us verifiers are urged to only request information that is strictly necessary for a specific transaction to occur for authentication. This is important for at least two reasons. It reduces the liability on the verifier side because they avoid handling highly sensitive information. It enhances all their privacy by only asking for information that is necessary for a specific transaction. That's important because if you decide to not only to use for authentication, but also to store then those information, you are essentially creating an honeypot for malicious user that want to attack you to retrieve important information. So in some sense, the principle of data minimization protect the holder, but also use a verifier. Bearer credential. We anticipate a bit also this kind of credential. Essentially are not verifiable, but something that you can use, but really in low risk scenario. So in scenarios, in system in which presenting such a kind of information, self-asserted or generated by an issuer but without signature, can open to possible misuse. So we can use them, pay attention to the purpose. In this particular kind of credential, what is missing is the DID into the credential subject, and so we are also reducing the capability of the verifier to use this unique identifier to correlate the user. Then correlation during validation. What does it mean? Another possible scenario in which someone can correlate the behavior of a particular user is not the verifier itself when he verify the credential, but a dirt system that we use in the interaction. Think, for example, to the web service that maintain the bit string for dealing with revocation. If I'm the owner of that service, I don't behave correctly, I know exactly who is interacting with which verifier. Because every time a verifier receives a presentation, the verifier check for revocation the status of the credential itself, and so you can understand something in terms of who is interacting with who. Storage provider and data mining. Sometimes you use other party software for a wallet. So you are not responsible in at first glance of the storage of your verifiable credential. And so it's very important that you select a service that put in place secure storage with all the best practices, because in that case, this is the let's say the perfect honeypots, because there are all the credentials with all the information of the user. So something that a malicious actor want to attack to collect those information. That's why, my personal opinion, more, or in other case, you have a wallet, but you decide to store in cloud or to backup in cloud the credential or other secrets. So since there are several possible options for not only to get access, but also to say data mining solution to collect those information. Here the specification is telling us pay attention to the storage of the credential. My personal opinion, local storage is a much better solution if you implement the security with the correct practices. Aggregation of credential. Again, the more information that you give to a party, the higher is the probability that analyzing in the right way those information, this third party can understand something more on your identity. And so essentially, you increase the possibility for this third party to understand something more. The typical case is when you combine credential because you want to, let's say, prove your different claims of your identity, but putting those information together when correctly analyzed, let the verifier understand something more. This is again the case in which the sum of true information provide more information than the true independent information. So everywhere possible, avoid the use of aggregation to put together verifiable credential. It is much better to redesign the issuing process and provide credential that minimize the information but provide the right amount of information for a specific verifier to authenticate and authorize the holder. Pattern of use. This means that we need also to pay attention to all that technique that consider the pattern of presenting a particular verifiable credential, so to each verifier, again, to extract further information about our behavior, preferences, or to link us. Then legal processes. It's something that typically is not considered. Sometimes for legal purpose, the owner of these systems need to provide the information on request to law enforcement. So it's super important that we also inform the user of such services as that in some specific cases, some of the identity information are shared with law enforcement and we need to inform and specify in clear way what are the kind of information that can be shared if requested by with law enforcement. Sharing information with the wrong party. This happens sometimes. So we need to implement typically in the wallet agent all the checking mechanism, all the mechanisms to be sure that we are not sharing information with a wrong party, for example, with a verifier. This can happen, and so it's important that essentially these wallets provide clear information to the end user about the third party, the verifier he is sharing the information with. Pay attention to data theft. Again, this is something we already discussed with other in other consideration. essentially we need to avoid concentrating identity information in single point that can be then the right honeypots for malicious users that are interested in retrieving identity data. Frequency of claim issuance, that's, let's say, related to a previous consideration regarding the pattern of use. So also analyzing and monitoring the issuer and the claims that this issuer is issuance to user can be used to retrieve personal information or information about the behavior of the user itself. For sure, prefer the single-use credential. Every time is possible to issuance a credential that the holder can use just once. This is a real help in terms of privacy of the user, because the second time he, for example, access the same service is going to present a credential that is typically different from the previous one, and so these help in reducing the capability of the different actors, the verifier itself or third-party services that are involved in authentication and verification of the credential, to understand and correlate and link the the user of this credential. So whenever possible, this is a good choice. Of course, this means increasing the load at the issuer side. So always there are trade-offs: security and performance, privacy and performance. If we are in a system in which the number of single-use credential issuance request is very high, maybe is not a good solution in terms of performance, even if it is a good one in terms of privacy. In other case, with let's say less frequent access to services, and so to the issuer for requesting a credential, in this case, we can use single-use credential and reduce privacy concern for the holder. Issuer cooperation impacts on privacy. This is the last one, and we can, when we consider this consideration, we can think, for example, to the adoption at the issuer side of signature algorithm that reduce the generation of always the same signature over the same parameters. So also the issuer can take some decision, the developer of the issuer can take decision in terms of selection of the proper algorithms, for example, to avoid correlation through the signature. So these are, let's say, quite a big set of consideration that the the designer, the developer of this specification provide us. Of course, there can be many others. The point, the main point for you, the takeaway for you is that consider this suggestion for sure when you want to implement issuer wallets or verifier agents, but pay attention to all the technology around the simple implementation of an identity framework, because sometimes security or privacy concern comes from the what is around. Let's think, for example, to the case of tracking the IP source of the packets that carry your information, your identity information. Okay? Now we can have a break and then we'll start with the issuance and verification flow.
Ci vedevamo, ma la nostra ultima lezione con lei è domani o settimana prossima per via dell'ora di classe?
Now, what we are going to discuss in the remaining part of these lessons is the verifiable credential and verifiable presentation exchange protocol. What we have said until now is essentially that in the triangle of trust, the entities exchange verifiable credential and verifiable presentation. But how? With which protocol they use to exchange this information, and what are the information that the two peers exchange to really give the holder the possibility to ask a verifiable credential or the holder to present a verifiable credential. For many years, these protocols were not defined. So the first implementation adopted customs, let's say, messages to exchange VC and VP. Fortunately, in the last 1 year, two possible protocols has been defined and specified. And in particular, today, we will go through the OpenID Connect solution. Why this protocol, let's say, are so important? Because for interoperability purposes, we need to have the endpoints that know exactly how and what information have to exchange to implement the logical issuance and verification and presentation process. Now, before entering in the details of this protocol, let's go through the verifiable credential issuance logical steps and the presentation logical steps. So, this is important because in this way you see and you can map the logical steps, what you want to do, what you want to exchange, with then a formal protocol to exchange this information. So given an holder willing to get a verifiable credential, the issuer. Collect the identity information from the subject. Verify the information and makes the related claims. Pay attention that these two steps are typically custom business. I mean, any issuer, based on the kind of information that he need to verify to then generate a verifiable credential, can implement a custom verification process. Let's make some example that, in my opinion, depend on the scenario. If I want to, for example, issue a verifiable credential that state if you are above 18, for example, I need to check your physical ID. So this means that a process that exchange information on your physical ID with the issuer, the verification of this information, and then the generation of the verifiable presentation need to be in some way or needed. Sometimes the interaction in the real world, in other case, everything can be, let's say, within the informatical information systems. It depends how you want to implement it. But things, for example, to identity for objects. I think you have already done the trusted computing, TPM, and so, okay. Imagine an object. You want to provide a verifiable credential to an IoT device. The device, for example, is equipped with a TPM. What can be the kind of information I need to verify from the other side? There is an IoT device that is part of my system, and to decide if provide or not a verifiable credential. For example, you can go through a process of remote attestation if from the integrity point of view the device is correct and behave correctly. At that point, this can be the verification that give the issuer the right to provide the verifiable credential. You can think of any process that you want based on the scenarios. You are working with people, you are working with objects, you are working with organization to implement these first two steps, logical steps. Then the issuer has the related claims to put in the credential subject of the verifiable credential, generate the credential, sign the credential, making the verifiable credential, making it a verifiable credential, update the VC related status information. That means, for example, to handle revocation, set to 0 the bit string associated with the unique identifier of that credential, issue the verifiable credential to the holder. Okay, from the pure logical point of view, these are the steps. Of course, something has happened before. The issuer, as any other peer in the ecosystem has generated his own self-sovereign identity. Just to recap, what does it mean? The issuer has generated his key pairs. It's generated is the ID, generated the DID document and store the DID document on the VDR of choice, and request his own verifiable credential. Sometimes issuers not always have their own verifiable credential. Now, the verifiable credential, the issuer also store, updates, and set his own data structure for dealing with the revocation of the verifiable credential that are going to issue. Not only, one more step, published on the verifiable data registry also the schema of the verifiable credential that is able to issue. Okay, just to see the whole picture. Now, verifiable presentation, verification logical steps. So now we take a look at the other side of the triangle. So given an holder that presents a verifiable presentation to a verifier to be authenticated and be authorized or not to access a service of a resource, what are the logical steps of the verifier? The verifier receives the verifiable presentation. So, first of all, need to retrieve the DID of the holder from the verifiable presentation. Then resolve from the DID, understand the DID method. If that verifier has an implementation of that DID method, can resolve the DID to retrieve the DID documents of the holder and select the proper, if not instructed by the DID itself, select the proper verification method equal public key of the holder. At this point, can check the proof on the verifiable presentation and also the validity of the metadata in the verifiable presentation. In these steps, let's say, I didn't consider, but it's important to do that the verifier has also provided a challenge to the holder before generating the verifiable presentation. So, after the validation of the signature of the holder on the VP, of course, you need to verify the challenge on the VP itself, just to be sure that is exactly the one provided from the verifier. Today, we also added a small portion of information. Also, the validation happens in the validity until you are in the validity period of the challenge. Okay? Good. Now, you can unwrap the verifiable presentation and extract the verifiable credential. And so you know that verifiable credential is signed by the issuer. So you retrieve the DID of the issuer from the verifiable credential. From the DID itself, the verifier understood exactly the DID method to use to resolve the DID, interact with the VDR, resolve the DID, retrieve the DID documents. From the DID documents, select the proper verification method, equal public key of the issuer, and use this public key to verify the proof on the verifiable credential. Then you remember that a verifiable credential has three classes of information: proof, credential subject, metadata. So once the proof has been verified, the verifier check the validity of all the metadata. Is valid, it's not valid. The expiration of the credential is in the future, is already expired. No, validate the different information of the in the metadata of the verifiable credential. Then the further step is check the status. The verifiable credential is authentic and valid. Has been revoked or not? So a further check. This means that in this particular step, the verifier interact with the service that give him access to the bit string that provide information about the revocation status or suspension, for example, of that particular verifiable credential. At this point, the verifier can extract the credential subject and go on with further authorization steps. These two logical flow more or less involve all the layers, technologies, and data models that we have seen until now. Do you have any question about these flows? Everything is clear? You want me to recap something? Do you have some question on this? Because this is crucial to go on. Okay. Now, how can I exchange all this information? Which is the protocol that I can adopt? As I already told you, until 1 year, yeah, 1 year ago, there were no specification for these protocols. Now we have two options. The first one provided by OpenID Connect, that is another community association of people and business organization interested in specifying open solution for identity, and also the W3C credential exchange protocol. My personal opinion, the first one reached a good level of maturity. In my opinion, is what the whole identity community is going to use in the next years. The other one is a bit less specified, and not only the good news is that the solution from OpenID Connect let also you use as a lower layer protocols W3C credential exchange. So that's why in this module we will go through the specific principles of the OpenID Connect solution. We have two specifications, main specification, of course. The first is OpenID for verifiable credential issuance. So the protocol that holder use to interact with the issuers. And OpenID, of course, for verifiable presentation. The protocols that the holder use to interact with the verifier. Roughly speaking, this specification defines the API for the issuance of verifiable credential of any format by any issuer. So the specification from OpenID for verifiable credential issuance subtend any type of verifiable credential. So there is no specific, there are no custom specification based on some kind of verifiable credential. So we can use it for any type of verifiable credential. What are the endpoints of this protocol? First one, endpoints are essentially the endpoints of this API and how and where they contact themselves in the interaction. Credential endpoint, from which one or multiple verifiable credential with the same format can be issued. This is mandatory. So in the implementation and the adoption of this protocol, for sure, you need to implement, specify and implement the credential endpoint. Now, if you remember the logical steps, we sometimes need the use of nonce and challenges for freshness. So in this specification, there is one more endpoint, that is the nonce endpoint, from which a fresh nonce value can be obtained to be used in proof of possession of key material. Why this? Someone of you can, let's say, further explain this concept? Remember which information is within the credential subject of a verifiable credential. Which one? The most important. You see, credential subject, the first information, the first property. Which one? ID, the DID. And so, if I am the issuer, I have to put your DID as a claim in a verifiable credential that I am going to issue you. I want to check that you are the owner of the DID, the controller of the DID. So the issuer put the DID into the verifiable credential only after at least a challenge and response protocol to verify that you, beside the information about your identity that you are sharing with me to create the verifiable credential, are the controller of the DID. Otherwise, I don't bind my verifiable credential with your DID, and I will never issue you the credential. Okay? Pay attention that when, in particular, in layer 3 of this framework, you have the wall technologies that work together. Okay? So that's why the protocol, the specification of this protocol specify these endpoints. So a fresh nonce value can be obtained to be used in proof of possession of key material in a subsequent request to the credential endpoint. This specification doesn't use specifically the term DID, but use the term key material. But we all know now that behind a DID there is a key pair, okay? That's why this specification can enable the use in the future also of other identifier, okay? The centralized identifier, DID, are one type of identifier. So that's why you, in this specification, if you want to, you can read it. It's quite simple to read. You will see the term key material and not DID specifically. And this is optional. You can have it, or you can have an implementation in which the credential endpoint directly provide you also these nonce. Another important endpoints is the deferred credential endpoint. This is needed to enable the deferred delivery of a verifiable credential. There are some cases in which maybe the issuer need time to verify all the information and generate the claims. That can be, or can also be used to deal with very high rate of issuance request, for example. So in some cases, the issuer does not provide you immediately the verifiable credential, but give you a time period to wait before receiving the verifiable credential, or at least the designer of this specification also consider this possible use case. Also, this endpoint is optional. What are the mechanisms of this protocol? Mechanism for the issuer to make a verifiable credential offer to the wallet VC offer means what type of credential I can issue to encourage the wallet to start the issuance flow. Of course, I need to know which kind of credential that specific issuer can provide me. Optional. A mechanism for the issuer to receive notification from the wallet about the status of the credential that have been issued. This is an endpoint that's for sure a verifier can use, but also, and sometimes happen, the wallet itself want to know periodically if once one of the verifiable credential he is handling has been revoked or not. Because remember, the issuer revocation happen when the issuer itself decide to revoke a verifiable credential. Sometimes can be the wallet, the user, the holder that ask for any reason to revoke a verifiable credential. For example, because he lost the control of the DID or any other reason. There is one, it's not specifically revocation, but there is one more case in which a verifiable credential is not valid anymore. When when ah, okay, right. You must start, let's say, now that you have more or less the whole framework in your mind, start making new questions about the different use cases, different actions, different protocols, and exchange of information. This helps you a lot in understanding the whole framework. Optional, this one. Of course, the mechanism for the issuer to publish metadata about verifiable credential it can issue. So this specification, let's say, divide from VC offer, that is an information that we are going to, the issuer is going to provide to the wallets to say, hey, I can issue this type, this other type, with another mechanism to publish the metadata, for example, the schemas of the credential on the VDR of, again, of the verifiable credential that is able to issue. So endpoints and mechanism. Now, there are plenty of issuance flow. First one, authorization code flow. Issuer can obtain end user information to use into a verifiable credential using end user authentication and consent at the credential issuer's authorization endpoint. But there is also a pre-authorized code flow. Issuer can obtain end user information to use into a verifiable credential using out-of-band mechanisms outside of the issuance flow. What does it mean? That within the issuance flow, I can go through authentication, authorization directly in the issuance flow, or I can use a out-of-band solution to be authorized to receive this verifiable credential. And so I'm pre-authorized when I go directly to the credential endpoints to request my credential. Can be wallet initiated or issuer initiated. So the issuance flow can be started by the wallet or by the issuer. Ideas? Ideas for example, an issuer initiated. Let's think about it. Then we will see in specifically. Essentially, I'm an end user. I know that I have to contact the issuer and use my wallet and go directly there to receive my VC. Or maybe I receive information from an issuer by email, the QR code, whatever, that I can obtain my VC from that specific issuer and start the process. So this specification of the protocol provides us, again, freedom for the implementation of the solution that we want. Same, the issuance flow can be same device offer. So end user may receive the verifiable credential offer from the issuer on the device the wallet resides on. Here, okay? The wallet is here. I receive the offer directly here. Or cross device credential offer. C'è bisogno che parta Siri. End user may receive the verifiable credential offer from the issuer through any other means, such as another device or email, so that the verifiable credential offer can be communicated to the wallet. Sometimes the device used by the end user does not have the wallet, because maybe your wallet is in cloud, and so you can also interact with your device and your wallet somewhere else with the issuer to request and receive your verifiable credential. And of course, immediate or deferred. That's why the endpoints. Okay? So I immediately receive my verifiable credential or after a given period of time. Endpoints, mechanism of the protocols, issuance flow. Full freedom to implement this interaction between holder and issuer based on the kind of system that you want to deploy. Let's start with the authorization code flow. So, in this specification, we have one more entity, two entities with respect to what we normally see in the triangle of trust. These entities are the end user, because in this specification divide the end user from the wallet. So no, previously in general description of the framework, we have the holder, okay? Holder of a verifiable credential. In this specification, the holder is end user and wallet. Do you remember also when we went through some of the security consideration, we said that it is very important to implement in the wallet specific measure to authenticate the user, no? So this specification use different term of entities, but in the end is always the same identity model. So end user and wallet. that can be what we called older before. The authorization server, of course, this is a new entity that is used to implement an authorization code flow or pre-authorized authentication code flows that is part of the service implemented by the credential issuer. Again, with respect to the triangle of trust, authorization server and credential issuer can be considered the issuer. Now, the authorization code flow have start in two different way. Of course, you see in this graph, arrows are messages, the line of time here, vertical. So you can start with 1A option, a wallet initiated flow, or 1B issuer initiated flow. Wallet initiated flow begin with the end user request a verifiable credential via the wallet from the issuer. So it's the end user that start. Issuer initiated flow begin with the issuer generating a verifiable credential offer that is communicated to the wallet. Okay? QR code, URI, whatever. So the arrows say the end user that start or the credential issuer that start. In the second case, issuer initiated, what the issuer provide to the wallet is an offer. I can provide you this, and this type. Step number 2. What I need at this point are essentially the issuer metadata. So wallet use the verifiable credential issuer URL to fetch the issuer metadata to learn the verifiable credential types and format. Remember that this protocol is has been specified for any VC format that the issuer support and to determine the authorization and credential endpoints. So where to contact the authorization server, where to contact the credential issuer to receive then the verifiable credential. Both endpoints required to start the request. So the arrows from the wallet to the credential issuer. Of course, after a request, there is a response. So number 3, wallet send an authorization request to the authorization endpoint, which process the authorization request, which typically include authenticating the end user and gathering his consent. We always have to remember that any action that deal with identity require the authentication, the information, and the consent from the user. No? Remember the security consideration, software trust boundaries. We need to develop software that is trusted by the user of these agents. So the wallet send an authorization request to the authorization endpoint, which process the authorization request, which typically include authenticating the end user and gathering his consent. Number 4, the authorization endpoint return the authorization response with, of course, the authorization code upon successfully processing the authorization request. Number 5. Wallet send a token request to the token endpoints. You can imagine that the token endpoints is part of the authorization server with the authorization code received at step number 4. The token endpoint return the access token in the token response upon successfully validating the authorization code. Okay? So I request the authorization. Everything is successful. In the end, I have the token to access. Number 6, wallet sends a credential request to the issuer credential endpoint, the first endpoint that we addressed at the beginning, with the access token and the proofs of possession of the private key of the key pair to which the issuer should bind the issued VC. Let's make it simple. I have to demonstrate that I'm the controller of the DID. Okay? Upon successfully validating the access token and the proof of possession, the issuer return a verifiable credential in the credential response. Okay, so token and proofs, the credential. Authorization code flow with immediate issuance of the verifiable credential. But if the issuer requires more time to issue a verifiable credential, it may return a transaction ID and a time interval in the credential response instead of the real verifiable credential. The wallet, as we are essentially in case of deferral VC issuance, and so the wallet send a deferred credential request with the transaction ID to obtain the VC after the specified time by the credential issuer. Okay, let's see once again this authorization code flow, and then tomorrow we continue with the pre-authorized code flow. So holder, issuer, and verifier. Holder, end user plus wallet. Issuer, authorization server, and credential issuer. Essentially the same issuer that has the authorization service and the real issuance service. The user can start directly with the wallet, or the flow can be issuer initiated, 1A or 1B. So end user select the credential, or 1B credential offer with all the credential type from the issuer to the wallet. Number 2, obtain issuer's credential, issuer's metadata. Authorization request with types of credential to be issued. In the middle, of course, there is the consent of the end user. Authorization response with the code of the authorization response. Token request with the authorization code received from the issuer. And then token response. That means I received the token back. At this point, I can directly interact with the credential issuer, providing access token and, again, the proof of possession of the key pairs. The specification key pairs equal to DD. And the credential response that can be immediately the verifiable credential or a transaction ID that the wallet use after a specified time interval to recontact the credential issuer and receive the verifiable credential. This happens when the time, for example, for the credential issuer to produce the verifiable credential cannot be immediately done, but require a given amount of time. Any reason. Okay. See you tomorrow, guys. 1 hour and a half with me, and then with Professor Azzeni for exercises.